So a bit of a messy title. So AI scalability in drone mass use and role in different parts of field operations. And I would have to say that I just love the previous presentations as it's kind of building up, and they are essential part of use cases that are coming up. And I'm usually having this habit of having disclaimers and everything. So what you will see is pretty much you can basically conduct it from public sources. I'm presenting quite many of the things as my own view, as I don't want to put my company into shame. So please bear this on mind, and also do not expect very technical presentation. So as a product manager, I'm mostly concentrating on the use cases, bigger picture, etc. This kind of a higher than a technical detail drivers. But I hope this is okay. So I'm moving to table of contents, which look like this. And let's first have a quick look at the big picture, the mess we are facing when using drones in masses. And now let's be honest, in warfare, there's no point of going around this fact. Then views to consider when you are using the things, after which running quickly through a couple of use cases and key points, and in the end, sort of a diagram and quick thinking, AI cost versus benefit versus mass, this kind of a thing. And going to big picture. So yes, it's a battlefield. There's lots and lots of things happening, traditionally completed by human beings, intelligence swarming into the field, on the background, command and control systems leading the thing, collecting the data, giving overall commands then after the analysis for individual contributors there on the field, that what's actually happening. And as you can imagine, there's lots and lots of players over here in order to make everything work. And when you are having lots of players out there on the field, obviously the bullet number one, costs. How much money can you spend over there? How much time and effort does it take to develop AI to do its job there on the field, versus how much does it cost if there's a man in the loop, so human being doing at least parts of the mission that is wanted to be accomplished. And then second thing is that on the cost side, that where does the AI calculation take place? Is it edge computing? Is the computing done in the back end? How much can you expect that drones will be lost? The more you expect them to be lost, the more expensive the operation obviously comes. So you might not want to put latest NVIDIA core systems there to be lost in the action. Then second one is the reliability. So ease of use, first of all. There will anyway be human beings. Will whatever is being developed be so easy to use that you will not just throw it to the trash can on the second minute of the operation as it's not functioning properly? Is there just one or two buttons, or is there a complete keyboard which you will need to learn, etc., etc.? That's part of the reliability thing. Then how easy it is to learn to use different kind of tools. Obviously, that kind of dictates that how widely different kind of solutions will spread overall. The same principles as, let's say, in consumer electronics, for example. Then the technical reliability. which you could say that is the AI solution. For example, is it so reliable that it's always, almost always, or almost never does its job? So what is the level of confidence that AI works properly until the very end, and you can kind of, you know what probability there is for the mission to be completed. Overall, safety of solutions is obviously important. So how do you place different kind of backend calculating systems? How do you communicate? How do you hide? So which kind of trace you leave out of yourself to be found there on the field? Then the AI roles, this is not official terminology, but kind of starting from the very basics. So is there a kind of on need basis assistant? For example, some sort of a portable computer from which you can find health tips or first aid tips to guide you through when you are there in the action, which is having very kind of a specific purpose. Are you having some kind of a proactive assistant that is making you proposals, what you should be doing while making the mission going forward, which then you as a human being check that, okay, this looks good. Let's go around that hill, etc., etc. So kind of the same steps as in industry use cases. Then third bullet, independently contributing parts of the mission. For example, navigation is a good example of this one. After which man in the loop for kind of finalizing the mission, doing the recognition with a good certainty of an object, etc. And then fourth, independently contributing complete missions, which latter then leads on quite many cases to ethical questions. Well, there was a good example of that year 74 movie, a thermonuclear device. Would you like this kind of a device to make the decisions on behalf of the whole world, or do you need a man in the loop to have the ethics also involved in the action? Okay, let's go for the first use case, which is briefly logistics. At least two quick use cases on logistics. So making the deliveries out there on the field, having less human beings involved, and this way making less human beings getting wounded in the action. These things should be rather easily automated, as there are service routes usually taking place on which you can quite often have a data, how do they look like, and you can adapt to the GNSS denied environments by having a machine vision, etc. Kind of things that Jouko Kinnari from Saab showed in the first presentation. Then second one is the rescue missions, that how can you evacuate human beings from front line? Do you have several people escorting, or would it make sense to have a automated UGV doing the job over there, and in case for some sad reason the rescue mission is being hit, then the wounded person would be the only one lost in that case, but also kind of a safety issue on this sense, but requiring the navigation capabilities in rather harsh environments. Second use case is a reconnaissance. So fly out there. First of all, mission control may have a proposals from AI based on what's being learned. Human beings can then make the decisions over there. You can have a certain loitering tasks given for the UAV over here, so that UAV is loitering in the air, and in case something interesting is being seen, maybe fly closer or direct more of a sensors towards certain target, and these kind of semi-automated things. But machine vision, connectivity, real timing was mentioned that quite often it's not possible to send data from the field, so these kind of things would be needed. So everything is a bit of an uncertain, and it's endless swamp how you would need to use a different kind of connectivities and sensors to complete the missions with a 100% guarantee. But anyway, reconnaissance is something where especially machine vision is good help. Then swarming. Thank you, Fabrice, for a very good presentation. Maybe a couple of key points about the roles of a flock. In your demo, there was, I understood that there's similar UAVs flying back and forth, but let's also consider that there may be a different kind of roles in the flock when swarming is taking place. Some are having more intelligence, maybe doing the reconnaissance, having more edge computing capability. They can cost more as they are likely to be saved in the action and more likely come back home than the actuators, the cheap UAVs which are completing the mission on the field. So having this kind of rolling in place. And then the question is, of course, that how do these communicate? Do they know that they exist there, or are they being given directions from some sort of a backend so that they seemingly are swarming, but in real life they are doing just individual missions given by orders from the backend systems? Going for next one, targeting, AI targeted mass fire. Basically, there was a news a couple of weeks ago that acoustic sensors had been used to spot the artillery out there on the field. Collecting that data, comparing how quickly the signal comes from different places, and then doing the quick calculations about the places of the potential artilleries. That's one of the publicly known use cases on this one, which seems to be rather effective. And of course, connectivity here is important for the sensors as well as the mission proposals, so that after detecting what is the likely place of a object that we wish to reach, then we can have the proposals that how, where, which actuators should fly in. And the last one, this is actually my favorite because it's hopefully making the world safer, is the mind clearance. So first of all, reconnaissance, sensor fusion, lots of different sensors, metal detectors, SARs, SAR radars, thermal cameras, visual images, those all being combined, it will make you more likely to be able to spot unexploded explosives out there on the field, after which then the AI, or I would like to say usually advanced analytics and advanced algorithms, instead of an AI, they can then form the initial missions proposing that from where should you be starting, considering different kind of aspects, that where should the clearing actually start. Considering points may be that where there are most of human beings, where do own troops need to proceed next, and this kind of aspects to be considered and given for the calculation. And I would say that the human beings doing the decisions in the end of the day. So as you can hear what I'm saying, my view is that AI is on assisting role, doing small tasks, helping people on our current ages. Obviously going forward, but until enough computing power, proven capability to really reliably complete the missions, etc., etc., AI is more or less on the assisting role on different kind of an operation. So yes, I'm a bit boring. I would like to say that I'm a fan of AI, but I've also seen on my previous career that how much does it take to train the AI? How much does it cost versus what is the benefit and reliability in the end of the day? So I'm repeating this assisting role phrase over here. And then let's go for a last page, which is, I'm calling this sort of a diagram. I made this myself like the whole presentation. And there is now two curves. First of all is the red one, which is saying that the more costly and complex solution you are having, the more likely you are about to have just a couple of those. And the more cheap it is, the more likely you are about to have many of those in use. So mass use in reality requires the price to be pushed down. Then again, the green line over here is suggesting that if AI-based automated solution is providing higher performance than a traditional means of doing warfare, it's more likely that higher cost will be tolerated for the solution. So we can kind of get rid of the red line and have a bit more expensive gear sent out there. And the last one, if human beings are being saved, that obviously in a European philosophy means that then it's worth also paying more for the solution. And on these words, I would like to stop my presentation. It was very quick run through. Thank you for listening, and looking forward if there's any questions there on the line. Would be happy to answer. Thank you.